Questions 16 through 18. X and Y coordinates of a particle in motion as a function of time are given below. The X, for number 16, X and Y components of the average velocity in the interval from 0 to 3 seconds. All right, so average velocity we know is the displacement over the change of time. So displacement is final position minus initial position over the change of time. The change of time we know is from 0 to 3, so that's 3 seconds. And we know that the initial position at 0, time equals 0, when you plug t in, you're just going to get an initial position of 0. So it's really just the final position over the change of time. When we look at this, in the x, for the x component, we have x equals 8t squared minus 4t. Now the 1 is a constant, so that's not going to change as the time changes. So the time, the constant does not affect the average velocity here. So x at 3 seconds, we plug x in for each of those t's, and we're going to get 60 meters. Now remember, that's 60 meters over the change of time, which is divided by 3. So its velocity, average velocity, in the x direction is going to be 60 divided by 3, which is 20 meters per second. Let's take a look at y. Y equals 2t cubed minus 3t squared plus 6t. And remember, the constant's not going to change when we go to with the change of time. When we plug in 3 for y and do the math, we get 45. Remember, we have to divide that by the total time. So the average velocity in the y direction is going to equal 15. So we're looking for 20 and 15, and that comes up C. All right, number 17, the x and y components of the instantaneous velocity at time equals 2 seconds. So let's get rid of some of this. All right, instantaneous velocity. So we have position. So what we want to come up with now is the derivative of position. So we want velocity in the x direction at time equal to 2 seconds. So the derivative, we would multiply 2 times the 8, get 16t, and reduce the exponent by 1, so 16t. Multiply the exponent, which is 1, times the negative 4, and we're going to get negative 4, and reduce the exponent from 1 to 0, so it would be minus 4. So when we plug in 2 into t, we get velocity in the x direction equals 28. Right? So it looks like we already have our answer, but we can go ahead in the y direction. So velocity in the y direction at t equals 2, let's get the derivative. So we multiply the 2 times the 3, and we're going to get 6t. We reduce the exponent by 1, so that's 6t squared, minus the 2 times the 3, which is 6, and reduce that by 1. And 1 times the 6, and reduce that to 0, so it would be plus 6. Right? So when we plug in 2 for that, we're going to get 18 meters per second. So yeah, B works. All right, number 18. The x and y components of the instantaneous acceleration, this time at 3 seconds. So we want the acceleration. So we need the second derivative of position or the first derivative of velocity. So let's do that. So where is that? So we want to get the derivative of that at 3 seconds. So that's acceleration at time equals 3. So to get the derivative, we need to reduce, multiply the exponent times the coefficient. So that's going to be equal to 16, and reduce that from the exponent from 1 to 0. So it's just flat out 16. So the acceleration in the x direction is 16 meters per second squared. It looks like we have 3 choices. All right, so let's go in the y direction. So the acceleration in the y direction, let's get the derivative of this. So the first thing that we need to do is multiply the 2 times the 6, and we get 12, and reduce that to t minus 6, and plug in the 3 for that, and we're going to get 30 meters per second. So 16 and 30, we're looking at A.